Alright, I want to go through the instructions for our lab today just to clarify expectations and any confusing parts. So first of all, you do need a marble and a meter stick or ruler or measuring tape, just something that will measure centimeters or meters. We are using meters the whole entire time. And then we do need the timer from our physics kits. We'll use it as a stopwatch. So you're going to drop the marble from a few different heights and measure how long it takes to hit the ground. After the first height that I gave you is going to be 1 meter, you are going to choose the heights. And just make sure that you measure in meters the whole time. And they don't need to be extreme heights. You don't need to be dropping the marble off a roof, but make sure they're different. You can drop it when you're standing on a table or on a chair. Just make sure it's 5 different heights. And then make sure you're measuring each time you drop the marble. So first you're going to drop the marble from 1 meter high and measure how many seconds it takes to hit the ground. So I would have one person be the stopwatch person. Humans make mistakes, and if you keep one person being the stopwatch person, it will minimize that error. At least the error will be consistent. So have one person be the stopwatch person, and they're going to measure how many seconds it takes to hit the ground. And you're going to do this 3 times with each height because humans make mistakes, so we're going to record your different times, and every time you drop the marble, make sure you're dropping it from the correct height. Measure it each time, and then you calculate the average time with your 3 over here. Okay, and then the next one, you're going to choose the height, drop the marble from however many meters, you fill that in, and then record your 3 times, record your average time, and do this with 3 more heights down here. Okay, then next question, what was the initial velocity of each object? You guys can handle that. Number 7, fill in the table. Okay, so for heights, that's basically what distance did it fall. And remember to make it negative because the object is falling. So all those heights that you just recorded on the first page, they just go right here. Just make sure they're negative. And then you write your average times right here and the initial velocities. And then I gave you this formula to help you calculate the final velocity. So we don't need to memorize this formula. We're not going to use it at all really except to help us calculate final velocity right here. So don't worry about remembering that formula. And then this value should be negative because the object is falling, the velocity should be negative. Okay, so now we're going to use that stuff to plot a graph. It's going to be this average time value on the x-axis and your final velocity on the y-axis. So the height and the initial velocity were really just there to help you calculate final velocity. So I'm going to go over and show you an example graph that I made. Okay, here you go. So I want you to label your graph just like mine. Okay, so the x-axis goes along the top like this, and then the y-axis goes over on the left like this. So I put the x-axis on top because my final velocities are negative. They need to be below the x-axis to be negative. And then the scaling, I would keep it the same also for time. Every 5 lines, I made here 0.25, then 5 more lines, I put 0.5, then 5 more, put 0.75, so that means you're basically counting by 5s each time. And then on the y-axis, just counting every 2 lines and make it a whole number seemed to work fine. And they are negative. Okay, and then I gave you a little clip from my table that I had. So my heights are negative, just like I was explaining. The final velocities worked out to be negative also. Okay, and then I plotted these points. So this first one was 0.45 seconds and negative 4.44 meters per second. That is this first point. I went to the right 0.45 and down 4.44. Then my next point was 0.553 seconds and negative 5.42 seconds. So I went to the right 0.553 and down negative 5.42. And then my third point down here. Okay, then you want to put a line of best fit, and hopefully it is a line. Then let me go back to our worksheet. Okay, so what shape does your graph have? What should the slope of your graph be? And then now we're going to calculate the slope, the actual number. So a slope is rise over run, so I've broken it down to help you calculate that. So first, what was the most negative velocity? Go back to your table Let me show you my table. My most negative velocity is this negative 6.25. Okay, that's my most negative. That would go in this blank. And then what's the least negative? That is negative 4.44. That would go in the next blank. Then they want you to subtract them, so I would do my negative 6.25 minus my negative 4.44. And that's going to be the rise. Okay, and the rise should, you'll calculate your rise, and it should be negative. Okay, then we're going to get our longest time. My longest time was 0.64 seconds. That goes in the next blank, and then they want the shortest time, that is 0.45 seconds. So put those in your blanks here, and then you subtract them. So 0.64 minus 0.45. That's going to be my run. Now you calculate your rise divided by your run, and that is your slope, and it should be negative. Okay, and then question 12, why is it not negative 9.8? So I want you guys to kind of brainstorm and think, why is it not 9.8? Negative 9.8. Okay, so I will be on Blue Jeans. If you guys have any questions, definitely let me know, okay?